Hello everyone, welcome to my YouTube channel. My name is Himanshu Singh and today we are going to continue on the series called Multi-Modal RAG. Right, so in this particular video we are going to talk about the multi-modal RAG with Unstructured IO and LangChain. So till now we have covered few of the videos which is based on VisRag, which is based on Cole-Pali based method, which is very effective for the kind of creating RAG with multi-modality data, right? So let's say, but those models are something like they need a kind of a GPU, at least they need like a 16 GB or 8 GB of GPU to run those models itself, right? So in that case, if you don't have a particular kind of in configuration, so you can go ahead with these methods, and these are very effective methods, I can say, which deal with modality, right? So when I say multi-modality, right, it means that you have the data which is having a kind of different modalities in it. Let's say if you have a particular PDF, you are having images, tables, and text and charts, pictures, everything on the table itself, on this particular document itself. So how you can deal with that? So for this kind of problem, we have two approaches, right? So three options and two approaches are there. So in the first approach, guys, what we can do, let's say if you have any kind of document which is having all the modalities, you can use any multi-modal LLM. When I say multi-modal LLM or multi-modal embedding model, what that model will do, this model will somewhere embed all these modalities and store it inside the vector DB. So for example, you can have the clip model, you can have a kind of LXM BERT models. There are a few more models are there, multi-model embedding models are there, which are able to create a similar embedding for all of the modalities. So those models are good. Clip is from OpenAI, and Clip is a kind of base for all of the models itself, right? So these kind of models are there, so they can create the embedding and you can store it here somewhere. So what will happen, guys? Let's say if you store the embedding here, and if you query something from that embedding, like in the retrieval section itself, it will retrieve raw and text image. Why multi-modal embedding itself? Whatever you have stored here, it will kind of retrieve you the raw, like from that particular embeddings, from that particular store itself. It will retrieve the raw content, like image, like a text, like a table, and then again that similarity will be happening here. Similarity score will be generating between your data and your query itself. So now you got the retrieved chunk or retrieved context. That context would be having the raw table, text, and the raw image itself that can be fetched to any multimodal LLM, and that LLM will be able to answer you the question, right? So this is how it is happening in the option one and the feature one itself, right? So a feature or you can say approach one. So approach two, you have, guys, instead of parsing all the images to the multimodal embedding model itself, what we can do, we can get the summaries. So what we'll do, let's say we got some particular image, tables, and text, right? So all three modalities I'll be giving to the multi-modal LLM. Multi-modal LLM, I'm saying. That multi-modal LLM will give me the summary of all of three. Then we can store the sum, like once we got the summary of all, like image, table, and text, we got everything into a single modality, like a text only. So image summary would be in text, table summary would be in text summary would be already in text itself. Now, guys, what will happen, I'll just embed it. So text embedding will be happening here, normal embedding model will be used here, and text, it will be converted into a text embedding. So once we got the embedding of all three, we will be storing that into the multi-vector. What will happen in the multi-vector, we will be having the summaries embedding, as well as will store the original image as well, like a raw image as well. So we have the summary, we have the image, we have the summary of the table, we have the original or raw table, we have the summary of the text and the raw text as well. So it will be linked together. Summary will be linked to the original content. So there is again two options now. When you query something, when you query something, so what will happen, either when you query something, it will be matched with the summary embedding itself, and then it can retrieve in the option 2, it can retrieve the image summaries itself. It will image summary or text summary or table summary. So in the retrieved context, you will be having text as a response, and that text can be from anywhere, from the summary of the image, from the summary of the table, from the summary of the text. Means that will be dependent, and that will be based on the relevance score itself, right, or similarity score itself. So the thing is, like, here all the context which is retrieved from the retriever or database, that is only a text. So you can use any normal general LLM to answer that. Got my point? Now in the third option, guys, instead of retrieving the summary as a context, we will be retrieving the original chunks or original image. So when you ask something to this particular retriever, it will give you like, okay, this is the similar, like it will do the similarity with the summaries embedding. And now the summary, now you know, like this particular image belongs to this particular summary. So you will retrieve the original image, not the summary, right? So what is going to happen in that case, you will be able to save the data loss, because sometimes when you are creating the summary of the image, it's not getting that much good, right? So you get the original image, you get the original table, you get the original text, and now that all these things you'll be giving to the multi-modal LLM, and multi-modal LLM will be able to take it and give you the correct answer. So guys, maybe you are able to understand, like first option and third option is similar in terms of the generation part, in some terms of the context part, right? Context type part, right? But here the approaches is different. In the first option, you are creating the embedding of these all the modalities, right, using a multi-modal embedding model. But here you are creating the summaries into one modality, one text, and then text is kind of embedded and is stored, right? So this is how three approaches has been built, guys. What I'm going to do in the next videos, I'm going to create a kind of code, and will give you the demo code how you can create the different pipeline for the different three options, and which one is working well for your use case. And this will not require any kind of GPUs, guys. This is purely based on CPUs, so it can run on your system as well, right? So that is the three approaches. I just wanted to give you a high level overview about these things, and in the next video we are going to do the theory, the coding part only, right? So there is one more thing I just wanted to cover out here, guys, as that, you know, like you have images, you have tables and text. Now how would you understand, how model will understand, how code or pipeline will understand that this particular document has these three separate things, how you can segregate all your modalities? So there is one particular backbone of the system is there, that is called unstructured IO. So unstructured IO is something, it's a library, it's an open source library, guys, which is helping you to segregate all three modalities into the different buckets itself, right? Let me just show you that a kind of platform of unstructured IO. So this is unstructured.io. You can go here and visit and check the documentation of this. So in the documentation, if you see different welcome platform APIs, open source, so it's an open source library only. When you install it, guys, you are getting this partitioning part. So partitioning means when you have unstructured data, you want to partition data, you want to retrieve or extract the structured data from that, then you are using this partitioning. So for partitioning, for all different kind of documents, you have the different options like partition CSV, partition doc, partition HTML, partition message, partition PDF, PPT, everything. So we'll be talking about the PDF here. So from unstructured.partition.pdf, so you'll be importing partition_pdf itself, right? And then you can use it. It will create the different, it will segregate your figures, tables and text, and it will give you that. What I'll do actually for installing unstructured IO, I have seen like people who are getting issues, so I'll show you like how you can install this unstructured IO in your local. That will be needing Tesseract and PPOCR. right? Paddle OCR to be there in the environment variable. So that need to be installed because it is using OCR methods, right, to work with. So that's very good library actually for working with the multi-modality documents itself, right? So in the next video, I'm going to talk about this partitioning and all, right? The unstructured IO and the code itself. So this is what, guys, I hope you understood the approaches. I have documented all those approaches here in this particular notes. I'll share the link of this notes in the description, as well as I'll share the link of this partitioning or unstructured IO platform as well in the description. You can go ahead, check out that, guys. Also, if you have any issues, you can write out on the comment section, and I would love to hear that. So thank you so much for watching this particular video, guys. One more thing I just wanted to mention out here, like if you want any kind of mentorship, or if you are a college student, or if you want to change your domain to the data science and gen AI, so what we have just started a mentorship kind of program. So for that you can register, and I will be giving you the Google form link on the description of this particular video, so you can fill out that for Google form. So we'll be reaching out to you if you need any kind of mentorship. That mentorship is freely available. We will be having a consultant, and they will be reaching out to you, and they will help you to change your domain or to get a good job in this particular field itself. So thank you so much for watching this particular video, and yeah, stay tuned. Please like this particular video and subscribe to our YouTube channel. Thank you.